In this example, we are given the following parametric equation. X is equal to 3 tangent of t. Y is equal to 2 secant of t. And we're told that t ranges between, but not including, negative pi over 2 and positive pi over 2. Well, so now that we're given this, the request is to turn this into a rectangular equation. In other words, eliminate t. In other words, get an equation that solely involves x and y. Now, what I will use to do this is I will remember my trig identities. And specifically, I will remember that there are identities for tangent and secant. That tangent squared of t plus 1 is equal to secant squared of t. So now, if I can square these equations and work with them, I can figure out what the rectangular form should be. And by the way, if you have a hard time remembering this formula, just remember sine squared plus cosine squared is equal to 1. And if you divide this through by cosine squared, sine over cosine is tangent, cosine over cosine is 1, and 1 over cosine is secant. And there you go. You now have this identity after dividing through by cosine squared. Okay, so I'm going to square the x and the y. So I'm going to have x squared is equal to 9 tangent squared of t. I'm going to have that y squared is equal to 4 secant squared of t. Okay, and I'm going to look at this, try and see how can I get rid of the tangent and the secant. Well, first things first, let me isolate the tangent. So I'll do that by dividing through by 9. So I will have x squared over 9 is equal to tangent squared of t. Okay, now this is interesting. If I were to add 1 to both sides of this equation, I would now have tangent squared plus 1, which is secant squared. And I have an expression for secant squared right here. So I can make some progress with that. Notice that this isn't something that I look at and I immediately know what I'm going to do right off the bat. I know things I can do, and I start doing those, and I see more I can do as I progress. So I will add 1 to both sides of this. So I get x squared over 9 plus 1 is equal to tangent squared of t plus 1, which is equal to secant squared. So down here, if I can isolate the secant squared, I can set both sides of this equal. So I will do that. So y squared over 4 is equal to secant squared of t. So I have that x squared over 9 plus 1 equals secant squared, and that secant squared equals y squared over 4. So putting those together, I have x squared over 9 plus 1 is equal to y squared over 4. Now I want to just rewrite this in a way that's a little bit nicer, so I'll subtract the x squared over 9. So I have 1 is equal to y squared over 4 minus x squared over 9. And there we go. So I can tell that this is an equation of a hyperbola. It doesn't ask us to graph it, so I won't do that, but I will just mention that this is a hyperbola. If this had been a plus, it would be an ellipse where the x-axis would have a radius of 3 and the y-axis a radius of 2. But because it's a hyperbola, well, I'm sorry, because there's a minus, this is actually a hyperbola. So it's good just to recognize that in case it asked you to classify whether it's a circle, ellipse, or a hyperbola. And that is this example.